Well, hello there, folks. I hope you're doing well. In this video, we're going to be talking about Chapter 8.7, Solving Right Triangle Problems. You'll find this on page 232 of your workbook, and this is the last section of the chapter before the test. So, you'll be ready for the test after this, hopefully. First of all, we'll start with the try these. Write an equation that you can use to find the value of x. So the first one, we are given the angle of 67 degrees and the side length of 22 yards, and we want to find x. Well, if I look here, I have an angle, which is great, and I have an opposite side, because this is opposite the 67, and I'm looking for the hypotenuse. I know this is the hypotenuse, well, first of all, because this one's so short, but also because it's across or opposite the right angle. So this is the hypotenuse, this is the opposite. I need to use sine, because sine is equal to the opposite over the hypotenuse. So if I go back and look again at the different things that I've done in section 8.3, I can take a look and see that, well, for an unknown side x, that is the hypotenuse, that's equal to the opposite side, 22 yards, divided by the sine of the angle, 67 degrees. For this one, we're looking for an unknown angle x, and we have the side that is adjacent but not the hypotenuse, and the opposite side. So the adjacent and the opposite, that's dealing with the tangent ratio. But since I need an angle, I'm going to have to use the inverse tangent. So it is the inverse tangent, or second tan, of the opposite side, 10 miles, divided by the adjacent side, 3 miles. And that's it. That's the equation I could use. I could actually solve, but it doesn't ask me to, so I'm not going to. Moving on. So Jamie works for an oil company. He needs to drill a well to an oil deposit below the surface of a lake. The drill site is located on land as shown. What is the angle of depression for drilling the well? And round to the nearest tenth. First of all, what equation can we use to calculate x? Well, they've already told us that it's a tangent ratio, because looking here, we've got the hypotenuse. So this is the hypotenuse. Next to the well, I have the adjacent side, that's not the hypotenuse, and the opposite side to the angle. And the tangent is the opposite side, so 2,300 meters, divided by the adjacent side of 1,000 meters, or a kilometer. We could have done 2.3 and 1.0, or whatever. Either way you do it, x is going to be equal to the inverse tangent of 2,300 over 1,000. Now we calculate it. If you calculate the inverse tan of 2,300 divided by 1,000, I get an answer of 66.5 degrees. So the well should be drilled at an angle of 66.5 degrees. If you're actually doing this in real life, you would want to be incredibly exact, because just looking at this to find, say, the hypotenuse, the length of the hypotenuse, which is something that we could do now with our skills, or just even with the Pythagorean theorem, because we have a and we have b, so the hypotenuse is going to be the square root of a squared plus b squared. Either way, it's going to be like 2.5 kilometers. So over 2.5 kilometers, even the slightest miss on your angle is going to be a huge miss. You could miss the oil deposit completely. On short distances, the perfection of the angle, not so important, but long distances, very important. Anyway, so we got the answer, 66.5 degrees. And now, an example. Glenda's a forester. She uses a clinometer, or, yeah, I guess, because inclinometer? I don't know. It's to measure inclines. We'll call it a clinometer. A device that measures angles of elevation to sight the top of a tree at 48 degrees. Her eyes are 1.6 meters above the ground, and she is 7.2 meters from the tree. How tall is the tree to 1 decimal place? So we are going to be doing 2 parts here. And the book is going to walk us right through that. First of all, what equation can you use to calculate the length of the side opposite to the 48-degree angle? Well, we have the opposite and the adjacent, so that means we're using the tangent ratio, and we put in the tan of 48 degrees. It's equal to the height of the tree divided by the distance between her and the tree, which is 7.2 meters. To solve it, well, I just need to multiply both sides by 7.2, so I have tan of 48 degrees multiplied by 7.2 meters, which will give us the height. When I put that in my calculator, I get the answer of 7.996, which, I mean, we're supposed to just round to the nearest tenth. It is 8.0 meters. How tall is the tree? Well, you'd think it's just 8.0 meters, but if we go back to the diagram once again, this H here is 8.0 meters. So that's 8.0. But we still have the additional 1.6 meters for her height, because this 8 meters is from her eyes. So we need to take those 8 meters and add an additional 1.6 meters, which gives us a total height for the tree of 9.6 meters. And the reflecting says, how can you check your answers? Well, one thing that you could do is actually now check use the other ratios, use the sine ratio, sine of 48 degrees times the height, or no, not the sine, sorry, we could use the tangent. We could use tan of 48 degrees and then take the height and divide it by the tan of 48 degrees and make sure that it gives us the 7.2. Well, using this height here. I don't know. Just trust in your numbers, I guess. That's it. That's it for the chapter. Hope this was clear. If you have any questions, please do let me know. But I hope you have a fantastic day, and I will talk to you later.